So today we are going to be solving some paper 1 questions of AS level. We're going to be solving questions about atomic structure, ionization energy, and electronic configuration. So let's start with the first question, which says rubidium and bromine form ions that are isoelectronic. This word might be confusing for some people, but isoelectronic simply means that they have the same number of electrons. Obviously, since we have rubidium and bromine, that means that rubidium is in group 1, so it will lose one electron to form the ion, and bromine, since it's in group 7, it's going to gain one electron to form this ion. Each ion has 36 electrons. Okay, we know that the number of electrons, they are gonna be 36. Which was correct? Rubidium radii and bromine or bromide radii. Because obviously when it's gonna form an ion, it's not gonna be bromine, it's gonna become a bromide ion. And now we have to tell the difference in the atomic radius and their ionic radius. For that, we need to consult the periodic table. Let's do it for rubidium first. In rubidium atom, we can see this is rubidium in the periodic table. Rubidium has a total of 37. The top number is basically your proton number. Rubidium has 37 protons. Okay, it has 37 protons, and once it forms a ion, it's gonna have 30 because it's gonna lose one electron, it's gonna have 36 electrons, right? Over here, this is the rubidium atom. Let's write atom, and this one right here is a rubidium ion. For a ion, the number of protons remain the same because obviously you're not losing or gaining protons. So for a rubidium atom, an ion, the proton number is going to remain the same, but the electron number in a rubidium atom, it's going to be 37 electrons, but in a rubidium ion, it's going to be 36 electrons. That's going to be for rubidium. Now, when we have equal number of protons and electrons, we have a neutral atom. But over here, we have unequal numbers. So basically, we have more positive charge. You can see we have one more positive charge compared to negative. And when we're going to lose this one electron, which is in the last shell of rubidium, what's going to happen is that we're going to lose one shell. Because rubidium is in period number 5. It has 5 shells. In the last shell, it is one electron because it is in group 1. So what's going to happen is that when we're going to lose that one electron from period 5, we're going to shift towards period 4. A rubidium ion is going to have 4 shells because the 5th shell that contained the one electron, it's going to be lost. So now we have 4 shells. So since a rubidium ion, it's going to have 4 shells, so that means that the ionic radius has to be less than the atomic radius. So this is going to be correct. For a bromide radii, what's going to happen is that this is bromine right here. This bromine has 35 protons. So for bromine, now let's do this. The proton number is going to be 35, and it's going to be 35 over here as well. So bromine has Br 35 protons and 35 protons, and the electron number in the bromine atom, it's going to be 35 because the electron and the proton number in an atom is same. But the ion, when it's going to form an ion, it's going to have 36 electrons. It's going to gain one electron. Now what's going to happen is now bromine has a one more negative charge, and since it has one more negative charge, what's going to basically happen is it is more negative than positive, so the nuclear pull is going to weaken. So a bromine ion, it's going to have a greater radii than a bromine atom. Why? Because the positive charge is less in a bromine ion, the negative charge is more, and when you have a greater negative charge, you have more electrons, the atom expands. Why it expands? Because the distance increases, the nuclear charge decreases, and there are a lot of reasons. So it's going to be option C. Okay, now we have this question which says that the first 4 ionization energies for element X are shown in the table. Which ion of X is produced by removing an electron from a filled shell? Okay, so are they talking about a fully filled shell or a half filled shell? Let's see. Okay, this is the first ionization energy, this is the second, this is the third, and this is the fourth. So I can clearly see that there's no big jump. Unfortunately, I saw this entire thing and I figured out that there is no big jump, because in big jump you skip 1,000, at least a 10,000 for a big jump. And over here you can see a monotonous pattern. There's no big jump in the ionization energy. So when there is no big jump, we can say that we are not changing shells. What do I mean by that? Because look, since this is the last shell and we have 1, 2, 3, 4 ionization energies. So if there is no big jump, then I can say that all the 4 electrons are being removed from the same shell. So 1, 2, 3, 4, so all these 4 electrons, these 4, they are removed from the same shell. There is no change in the shell. So they're saying which ion of X is produced by removing an electron from a filled shell. By removing an electron. So we're talking about by removing 1 electron. Since all 4 electrons, since there's no big jump and all 4 electrons are being removed from the same shell, so when we're going to remove electrons from a filled shell, this is a filled shell, we're going to form a X4 plus ion. Why a 4 plus ion? Because we're removing the 4 electrons from a single shell, since there is no big jump. Which ions contain 1 or more unpaired electrons? Okay, I always recommend this, that when you are drawing electronic configurations for a ion like a 2 plus ion or a 3 plus ion or a 3 plus over here ion, the suggestible thing is that first you draw the electronic configuration of an atom. For instance, first draw it for a copper atom and then switch to ion, because if you directly draw it for ion, what you're going to do is you're going to remove electrons from the 3d orbitals first, and that's a very big mistake people do. So first let's write for copper atom. For copper atom, it's going to be a little confusing, but please bear with me. For copper atom, it might be a little confusing. Because it's going to be 3D. From here we start 3D 1, 2, 3, 4, 5, 6, 7, 8, 9. You think it's 3D 9. And if we write 3D 9 over here, 3D 9. Unfortunately, what's going to happen is that fully filled atomic orbitals are more stable. The d orbital, it has 9 electrons. It's going to be something like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's unstable. What's going to happen? That 4s is also filled. So 4s2, 1 electron from the 4s, this is going to shift towards the 3d, and it's going to become 4s1 and 3d10. 1 extra electron is going to jump over here. I'm writing for a copper only, not a copper ion. And now since I have to form an ion, I have to remove 2 electrons. So the first electron I'm going to remove from 4s, and the second electron I'm going to remove from 3d. So it's going to become 4s is going to be all removed, and it's going to become 3d9. So first write for atom, then for ion. Okay, which ions contain 1 or more unpaired electrons? So 3d9, this electron is going to be removed. If you're talking about 3d9, this electron is going to be removed, and now we have 1 unpaired electron over here. So yeah, this contains, now it's time for Mn3 plus. So Mn, it's basically gonna form what kind of ion? Mn1, not this is Mn. So it's going to become 3d1, 2, 3, 4, 5. It's going to form 3d5. So the last shell should have 3d5, and then there is 4s2. Always remember, you take out electrons first from the 4s shell, not from the d shell. Though the 4s shell gets filled first, but you take out electrons as well first from the 4s shell. So don't forget this. So we have to take out 3 electrons. We're going to take out the 2 electrons from the 4s shell like this, and then we're going to take out 1 electron from the 3d shell. So it's going to become 3d4. the last shell. And now we have to do it for an ion. 3 plus ion means we're losing 3 electrons. So if we take out 3 more electrons from the d shell, which is the last shell, it becomes 3d1. And 3d1 means your 5 orbitals like this, 1 2 3 4 5, and you only have 1 electron in the first orbital. So this also contains unpaired electrons. Now it's time for v3 plus. So first we're going to write for v, and then we're going to write for 3 plus. So v is right here, so it's 3d1 2 and 3, 3d3. Okay, so it's 3d3. The last shell is 3d3, and after 3d3 we have 4s2 subshell as well, don't forget this. And now we have to take out 3 electrons. The first 2 electrons we're going to take from the 4s shell, and then the 1 electron we're going to take out from 3d shell. So it's going to be 3d. Since we took out only 1, it's going to be 3d2. So 3d2 means like this. So it also has 1 or more unpaired electron. It has 2 unpaired electrons. So this is also going to be correct. So all 3 of them have 1 or more unpaired electron. The trick over here was that people forget the right 4s before 3d, and what then happens is that they take out electrons first from the 3d subshell. That's going to be extremely wrong. First you have to take out from the 4s subshell. Okay, which statement about a 3p orbital is correct? Okay, we know that 3p orbital is gonna have how many subshells? Not subshells, 3p orbital, how many 3p orbital? Okay, it's not telling about either it's 3px or 3py or 3pz. The 3p subshell has 3 orbitals. It can hold a maximum of 6 electrons. So we are talking about a single 3p orbital, about a 3p orbital. So it can only hold up to 2 electrons, because you know each orbital can hold 2 electrons. It has the highest energy of orbitals with the principal quantum number of 3. Now that's incorrect. Why? Because we have a 3d orbital as well after 3p, and that's on a higher energy because that's more away from the nucleus, and the more away you are from the nucleus, the more energy you have. It is at a higher energy level than the 3s orbital but has the same shape. No, a 3p orbital is something like this, while a 3s orbital is like this. So the shape is not same. Whereas the first thing that is has a higher energy, that's correct, but the shape thing is wrong. It is occupied by 1 electron in an isolated phosphorus atom. Okay, let's check. It should have 1 electron in an isolated phosphorus atom. So here we are with the phosphorus. Phosphorus is 3p1 2 and 3, 3p3. Yeah, that's correct. Phosphorus is going to be 3p3, so it's going to be 3p1 2 and 3. So all 3p orbitals, they only have 1 electron of phosphorus. That's correct. This is 3px, it also has 1 electron, 3py also has 1 electron, and 3pz also has 1 electron. So our statement number D is gonna be correct. Next question says in which pairs do both species have the same number of unpaired electrons in p orbitals? Now we're specified that we only have to look at p orbitals. We cannot look at any other orbitals, s or d. So first we're talking about an O atom. So let's check out from the periodic table. O atom is going to be 2p1, 2, 3 and 4. 2p4. Okay, so O atom should be 2p4. This is 2p4 in the last shell. And Cl plus 1. So first we're going to find out for Cl, and then we're going to take one out. So Cl is 3p 1 2 3 4 5, 3p5. So Cl is going to be 3p5, but you take out 1 electron, so it's going to become 3p4. So they have the same number of unpaired electrons because this is 2p4 and this is 3p4. Now F plus and Ga negative. So F plus is going to be 2p1, 2p2, 2p3, 2p4, 2p5. So F plus, this is going to be 2p5. And a G negative is going to be, so 4p1. 4p1 it's going to be, and then it's going to gain 1 electron. So it's going to become 4p2. This one right here is a 4p2. and they should have the same number of unpaired electrons in p orbitals. So definitely we can see, it has only one unpaired electron, where this one has two unpaired electrons. You can check it out over here. 2p5 means that 1, 2, 3, 4, and 5, whereas 4p2 means that 1 and 2. So over here we have one unpaired, and over here we have two unpaired. So I hope you get this. So now we have a sodium atom and a krypton 3 plus ion. You might think krypton is the noble gas, it does not form ions. This is a wrong thing. Noble gases do react, they do form ions. So we have a xenon fluoride gas like this, ZeF2. So noble gases, they also form covalent compounds. They do everything. So please have this tolerance and acceptance in A levels. So now this is not sodium, this is nitrogen, sorry. So nitrogen is gonna be, so this is nitrogen. This is 2p1, 2p2, 2p3. So it's gonna have 3 unpaired electrons. So that's 2p3. And krypton 3 plus ion. Okay, so krypton loses 3 electrons. So this is krypton, and we're forming a 3 plus ion. That means it's going to lose 3 electrons. It's going to have electronic configuration of arsenic. So arsenic is 1, 2, 2, 3, 4. 4p1, 4p2, 4p3. So that's 4p3 and 2p3. So they're going to have the same configurations for the p orbital. So it's only 1 and 3. They have the same, whereas the second one, it does not. Gallium and F plus don't have. Okay, the outermost electron in an atom of neon occupies a particular orbital. Okay, the outermost electron in an atom of neon, obviously that's going to be the 2p orbital that it's going to occupy. It's 2p6 for neon, because it should have a full outermost shell. Okay, which row shows the relative energy and shape of this orbital? So because it's a 2p orbital, so it should have a dumbbell shape like this, and the energy of the orbital relative to other occupied orbitals, obviously, because that's the last orbital. Because if I write for neon, it's going to be 1s2, 2s2, and then 2p6. So that's neon, and this is the last orbital, not orbital, I'd say this is the last subshell. So what's going to happen is it's going to have the highest energy. So compared to other, it's going to have higher or equal. So it's going to be option A. In which species is a lone pair of electrons? So we see this and we realize that it's going to be, in methane we don't have any lone pair on the central atom. In ACH3 we have 1, 2, 3. Over here we have a lone pair. Yeah, over here we are gonna have a lone pair. How? Because let me show it to you guys. We have this carbon, we have 1 hydrogen, 2 hydrogen, 3 hydrogens. Okay, we have 3 hydrogens, and now carbon has 4 electrons in its outer shell. So it's going to be 1, 2, 3, and 4. And now hydrogen, it's going to have 3 electrons, right? Hydrogen has 1 electron, so each hydrogen is going to contribute its 1 electron. So we have 3 electrons from the hydrogen, and since it's in negative, that means it's going to gain 1 electron, this negative thing. So if we have 1 more electron here that it has gained, so this pair that's on the top, it's a lone pair, so it has to be option C. For methane, we don't have a CH3 plus. We basically we have a hydrogen that does not have its own electrons. So in that case, that is not has anything to do with lone pair. And in CH3 as well, there is only 1 electron. There's not a lone pair. Okay, now we say an atom of calcium 48 can form a 2 plus ion. We know it. Which statements about this ion are correct? Okay, so basically what's happening is that calcium 48, this 48 is your mass number. It's not your proton number. 48 is the mass number. So we have our mass number. Calcium atom always gonna have 20 protons, that's correct. 28 neutrons, that's correct. 22 electrons, no, not 22, it's gonna have 18 electrons. Why? 2 plus ion means lost 2 electrons, so 1 and 2 are correct. 4 statements about W, X, Y, and Z have electronic configurations as shown. Which formula represents the compounds have boiling points below room temperature? Below room temperature means, what does this mean? They should form what kind of compounds? They should form covalent compounds, because if they're covalent, they're definitely going to be, you know, below room temperature. So this, I guess it's your potassium. 2H2. That means 8, 9, 10, 11, 12. This is your magnesium. And this 6, 7, 8. This is your oxygen. And this is your carbon. So firstly, CO2. So WX2. Obviously, this is going to be a gas, carbon dioxide. Then if we form magnesium oxide, obviously that's going to be ionic, and that's going to have a high melting and boiling point. Potassium oxide also an ionic. And if we form magnesium carbonate or something, I don't think that's going to react, so I guess it's only one. Okay. The first 8 successive ionization energies for 2 elements of period 3 of the periodic table are shown. So this is from period 3. Let's guess which group it is in, because when this it's gonna be in group 7. Why in group 7? Because these 7 electrons are being removed from the last shell, and this 8th electron is being removed from an inner shell. That's why it has a higher ionization energy. So but straight away I know this is period 3, which they told me, and group 7. For this I know that there's a big jump over here. So though they told me that this is period 3, I know it is group 2. So what is the formula of the ionic compound formed? So I'd go to my periodic table, check in period 3, this is my period 3. In group 2 I have magnesium, and in group 7 I have chlorine, so it should be MgCl2, magnesium chloride. Okay, a sigma bond is made between 2 carbon atoms in a molecule of ethene. Okay, you know that in ethene the first bond is the sigma bond and the second bond is the pi bond. Which diagram shows the orbital overlap that occurs in this bond? In a sigma bond, you are always going to form, it's going to be a SS orbital overlap. This one is a sigma bond, this one shows a pi bond, and this basically shows a, this is a hybridized orbital, I guess. Yeah, this shows a hybridized orbital, and this is something that, a S and P overlap. And this one is SP hybridized orbitals. Okay, which statement about an atom of Tc, I guess these are pretty basic questions. Let's move on. Which atom has exactly 3 unpaired electrons? An isolated gaseous aluminum atom. 3 unpaired electrons. So let's check for aluminum. Aluminum is gonna be 3p1. So that's gonna have 1 unpaired electron. So I don't guess it's aluminum. Let's check for phosphorus. Oh, it's gonna be phosphorus, because phosphorus is 3p1, 2, and 3. So this is the P block, and 3p1, 3p2, 3p3. So it's gonna be phosphorus. This is easy, pretty easy. Correct, referring to the common isotopes of chlorine. The isotopes have different masses. Yeah, they have. The isotopes have different number of nucleons. Yeah, that's correct. The isotopes have same chemical reaction. That's correct. All 3 are correct. They would have not a trend, they would have different physical properties, but the chemical properties are all same. That's easy. The first ionization energy of chlorine is greater than that of sulfur. Okay, why is that chlorine has a greater ionization energy than sulfur? Firstly, chlorine has a smaller atomic size. Why a smaller size? Because it has 17 electrons. 17 electrons mean it has a greater nuclear charge, a greater pull holding the electrons together, with sulfur 16 electrons, meaning 6 electrons in the valence shell. Shielding is despite constant. Okay, and then you should know one more thing, that uh, leave that thing. That's, a little bit advanced. But still, let's read which factors contribute. Chlorine has more protons in its nucleus than sulfur does. That's 100% correct. Chlorine has a greater electron. No, 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 no. Chlorine and sulfur both have 10 electrons shielding their valence shell, because chlorine is 17 and sulfur is 16. If you draw it for chlorine, the first shell, the second shell, and the third shell. For sulfur, first shell, second shell, and the third shell. Sulfur has 8 electrons, 8, 9. Sulfur has 6 electrons in the last shell, chlorine has 7, but the inner shells, they both have 2 shells that are shielding them, the inner 2 shell. This is the first and the second shell shielding its valence shell. This sulfur also has the first and the second shell that is shielding the valence shell. The covalent bond in chlorine molecules is stronger than those in... No. When you are calculating the ionization energy, you break the covalent bonds. You first break the covalent bond and then you calculate the energy. Why? Because otherwise that's going to be incorrect ionization energy, because the energy would be required to break the covalent bonds. So that would be incorrect. That's all for this video. Subscribe to the channel. That's going to mean a lot.